China has amazed the world with machines that look like they break the laws of physics. One of the most striking examples is the world's biggest tunnel boring machine, which started a project but came to an abrupt halt just 1,000 feet into a planned tunnel almost 10,000 feet long. Still, this setback doesn't hide the fact that China has mastered massive technology and construction like no other country. If you go to China now, you'll see roads, bridges, schools, and infrastructure that make even the most iconic structures in the West look small. Their bridges can dwarf the George Washington Bridge, and they're everywhere. These mega machines allow China to complete colossal projects faster, more cheaply, and with greater efficiency than anyone thought possible. Quietly but firmly, China has taken control of global mega construction. Today, a large portion of the world's biggest projects depend on Chinese technology. The question many ask is simple: what exactly are these machines, and how far can China push the limits of engineering? The answer seems to point in one direction, toward global dominance. At the beginning of the 2000s, China didn't even have a share of the global tunnel boring machine market. The technology had been refined in the West for more than 150 years, and it was considered too advanced and specialized for any new competitor to challenge. Yet by 2024, the situation had completely flipped. China had not only entered the market but taken it over, becoming the supplier for almost every major project around the world. To understand how drastic this change was, consider the comparison between the United States and China. In California, officials spent 16 years and billions of dollars trying to build a single high-speed rail line, and the project is still dragging on. In the same period, China managed to lay more than 40,000 kilometers of high-speed rail, complete with tunnels, bridges, and viaducts. These railways connected megacities like they were pieces of a giant Lego set. In doing so, China turned speed itself into a national strategy. What other countries struggled to achieve became routine for China. So, how did China manage to compress more than a century of progress into just 2 decades? Chinese engineers describe their method as concentrating all national efforts on major issues. Unlike the West, which spread out research across private companies and universities, China combined the power of the state, industries, and its workforce into one mission. They imported foreign machines, studied them, dismantled them, rebuilt them, and then scaled up production with astonishing precision. It wasn't a slow evolution but a rapid acceleration. The West moved forward step by step, through competition, trial, and error. China removed the delays and put the entire process on fast forward. The gap of more than 100 years was erased in less than 25 years, and this didn't happen by chance. The key was synchronization. By aligning industries, universities, and supply chains, China created a learning curve so steep that Western countries simply couldn't keep up. At the core of this transformation was not just machines but people, an engineering army trained to fuel this rise. Around 6.7 million engineering students are in training at any given time, and they are taught with strict discipline and a focus on practical results. These students don't just stay in classrooms, they are funneled directly into infrastructure projects and national development. Without this human resource, even the most powerful machines would be useless. This is where China's greatest strength lies. While Western nations often debate about work-life balance, China has built the world's largest engineering education system. Millions of undergraduates are enrolled in more than 23,000 courses across the country. This isn't just a statistic, it represents an enormous workforce, disciplined and trained, ready to take on the most challenging construction and innovation projects. Every year, China produces about 1.5 million engineers, 1/3 of the entire global supply. The United States produces less than a quarter of that number. This difference explains why China can complete 10 high-speed rail projects while Western nations struggle to finish one. The workforce exists in China, and it is structured for action. In the West, construction often halts for weekends, holidays, storms, or heat waves. In China, projects continue almost without pause. The idea is not just to build but to build at unmatched speed and scale. The workers, engineers, and machines are part of a system designed to move forward without unnecessary breaks. This relentless pace shocks outside observers but has become standard within China. The rise of China's mega machines is also tied to its broader vision of global influence. By controlling the technologies that shape infrastructure, China has positioned itself at the center of development worldwide. Many countries now rely on Chinese machines, expertise, and labor to complete their own mega projects. What once seemed like a faraway dream for China, catching up with the West, has turned into reality, and now China is setting the pace for everyone else. These tunnel boring machines, rail networks, bridges, and skyscrapers are more than just physical objects. They symbolize how China has learned to merge technology, education, and workforce into a single strategy. Where other nations see limits, China sees opportunities to accelerate and push beyond them. And this strategy has proven effective. From massive dams to ultra-long bridges and record-breaking tunnels, Chinese mega machines are not just tools, they are instruments of a new world order in construction. Experts who once doubted China now watch with a mix of shock and respect. The country has rewritten the playbook of engineering progress. Instead of waiting generations to master a field, China compressed the timeline into a fraction of what was once thought necessary. The result is a country that can reshape its own landscape at will and offer the same ability to the rest of the world. This is not just about machinery, it's about vision and execution. The West often debates, hesitates, and delays projects, trapped in bureaucracy, cost overruns, and public disputes. China, on the other hand, commits resources and people with an intensity that leaves little room for pause. The contrast is visible everywhere. While one high-speed rail line stalls in America, entire networks spring up in China. What makes China's achievement even more striking is that it was done in such a short time. Barely 2 decades ago, the country was seen as a follower in advanced engineering. Now it leads, not only matching the West but surpassing it in several areas. By building its machines, training its people, and aligning its industries, China has created a model of progress that looks unstoppable. Whether it's tunneling through mountains, bridging massive rivers, or laying thousands of kilometers of track, China's mega machines show the world what's possible when determination, education, and technology work together. The story of these machines is not just about engineering, it is about ambition, speed, and a new vision of progress. China has shown that what once seemed impossible can be made routine. And as long as it continues on this path, it will remain at the center of global construction, reshaping not only its own future but also the future of infrastructure worldwide. In China, engineering is treated like a national mission. Construction crews work around the clock in 3 continuous shifts, 7 days a week, no matter the weather. The machines never stop, and neither do the teams operating them. At midnight, a massive tunnel boring machine can be seen chewing its way through solid rock. One crew finishes its shift, another takes over instantly, and a third prepares in the background. It's not chaos, but a carefully rehearsed routine, a rhythm drilled into workers from classrooms to construction sites. Engineers in China are taught to view the impossible not as a barrier, but as a challenge waiting to be solved. The results of this relentless discipline are clear. By the end of 2024, China had secured 3.5 million valid invention patents, and more than half were already being used in industries. In many Western nations, patents often remain unused, collecting dust in archives. In China, they are turned into practical tools, weapons of progress that push the nation forward. This mindset of scale and discipline has changed everything. When a Western engineer predicts that building a bridge will take 5 years, a Chinese team can confidently respond that they can do it in 1 year, and then deliver on that promise. In Chongqing, 6-lane highways rise in the time cities like Los Angeles or London would still be caught in endless debates over permits and approvals. Now imagine this happening on a national scale. Every year, 1.5 million new engineers enter China's system. That's more engineers in 1 year than the entire population of many European cities. Multiply this by 2 decades, and you don't just see a workforce, you see a force of nature. And it's not only about numbers. It's also about focus. Millions of trained minds are directed toward mega projects, artificial intelligence, new energy systems, and the machines that turn impossible ideas into everyday reality. While the United States might spend a decade designing and approving a new tunnel boring machine, China builds multiple models in that same span, improving each one and slashing costs through mass production. The timeline of this rise is remarkable. In 2008, as Beijing prepared to host the Olympics, China still relied heavily on foreign tunnel boring machines. But by 2011, only 3 years later, the country unveiled its first domestically produced model. By 2017, China was exporting these machines to more than 30 countries. Today, 7 out of every 10 tunnel boring machines carving through the earth bear the label Made in China. And as if dominating the world's tunnels wasn't enough, Chinese engineers have now created machines so advanced they are described as breaking the laws of physics. Designed and built entirely in China, these tunnel boring machines are capable of performing in the toughest conditions. They can dig through soft soil in crowded megacities, cut through earthquake-prone zones, and complete tunnels faster, safer, and with unmatched accuracy. Some of these machines can dig up to 10 kilometers of tunnel in just a single day, and they can do so at a cost of only $10 million per kilometer. In comparison, the United States often spends 5 times that amount, about $50 million, for the same length of tunnel. One standout example is the CRCHI tunnel boring machine, developed entirely within China. It successfully completed the excavation of one of the twin tubes of the Jensen East Road Highway beneath the Qiantang River in Hangzhou. This massive machine measures 15 meters in diameter, making it one of the widest tunnel boring machines ever built. It delivers nearly 10,000 kilowatts of power and generates torque exceeding 42,000 Newton meters, with a top excavation speed of 50 millimeters per minute. The CRCHI model is proof of China's engineering power, combining scale with efficiency. Another example, the Caucasian TBM, highlights China's ambition even further. With an excavation diameter of 15.08 meters, a length of 182 meters, and a weight of 3,900 tons, it ranks among the largest single-shield hard rock tunnel boring machines in the world. Its enormous size allows it to move massive volumes of earth at an incredible speed, completing in weeks work that might take months elsewhere, all while maintaining perfect stability and safety. What makes these machines even more advanced is the technology behind them. China's TBMs use a sophisticated slurry shield system that allows them to operate in unstable ground and earthquake-prone areas. This system balances the pressure between the excavation chamber and the surrounding soil, preventing the surface above from sinking and keeping buildings and people safe. Hydraulic jacks and articulated joints give the machines flexibility, letting them adapt to shifting ground conditions. Meanwhile, the slurry cushions the tunnels against vibrations, ensuring stability even in regions known for earthquakes. These innovations have allowed China to power ahead with some of its most ambitious infrastructure projects. For example, the Ningbo-Zhoushan high-speed rail line, which requires cutting through some of the most challenging geological conditions, relies on these advanced tunnel boring machines. Without them, such projects would either take far longer or might not even be possible at all. This combination of discipline, scale, and innovation shows why China has pulled ahead in global mega-construction. By treating engineering as a campaign, by training millions of engineers every year, and by focusing those minds on practical, large-scale goals, China has managed to transform itself from a technology importer into the world leader in construction machinery. These machines are more than just tools. They are the physical embodiment of China's strategy to achieve the impossible and turn it into the routine. China has turned engineering into a discipline of precision, speed, and sheer scale. One striking example is the Jintang subsea tunnel, which is being excavated using a tunnel boring machine with a diameter of 14.66 meters and weighing 4,350 tons. It is the largest TBM in the world built specifically for subsea high-speed rail. In Guangzhou, a 15.07-meter TBM carved out the Haiju Bay Tunnel with barely any disruption to the busy city above. These achievements show how China combines immense power with delicate precision. Every Chinese TBM is equipped with advanced intelligent control systems. These systems constantly monitor torque, thrust, and ground pressure at the cutter head, adjusting in real time to keep operations efficient and accurate. Sensors and geological mapping tools work together to detect changes in soil or rock conditions, allowing the machine to adapt instantly. This means tunneling can continue smoothly without risking speed, safety, or structural integrity. Advanced models like the Linghang TBM, developed independently in China, go even further by supporting remote operation, intelligent excavation, automated safety monitoring, and adaptive systems that respond to the most complex geological challenges. China's tunnel boring revolution began in the early 2000s. At the time, many experts believed developing homegrown TBMs was impossible. Wang Duan, chief engineer at China Railway High-Tech Industry Corporation, recalled that early engineers in the country had never even seen a TBM in operation. Each machine had more than 20,000 parts and over 2,000 separate control points, an overwhelming challenge for a country just entering the field. But China pushed forward. In 2008, it unveiled its first domestically developed earth pressure balance TBM, called China Railway No. 1. The machine soon began work on the Tianjin Metro project and completed the tunnel in just 4 months, keeping ground settlement within an incredible margin of only 3 millimeters. This early success marked a turning point. China's TBM industry grew rapidly, driven by companies like China Railway Engineering Equipment Group, China Railway Construction Heavy Industry, and CCCC Tianhe Mechanical Equipment Manufacturing. One of the biggest breakthroughs was the development of ultra-large main bearings, the heart of any TBM. Bearings must endure enormous loads constantly while maintaining long life and reliability. To achieve this, Chinese engineers conducted thousands of tests, experimented with hundreds of material combinations, and worked closely with steel producers. Their efforts paid off. On October 12, 2023, CRCHI successfully produced the largest main bearing in the world, with a diameter of 8.61 meters. It was also the heaviest and highest capacity bearing ever made, a milestone that placed China firmly at the forefront of global tunneling technology. Chinese TBMs are not just massive, they are intelligent. Modern systems track the wear and temperature of cutting tools and slurry pipes, predict damage before it happens, and give operators real-time feedback. This combination of automation and data analysis means tunneling is safer, faster, and more precise than ever before. China's ability to achieve the impossible is not limited to tunneling. The country has become famous for record-breaking construction feats that astonish the world. A perfect example is the so-called 19 Days Wonder. In 2015, Broad Sustainable Building, BSB, completed the Mini Sky City project in Changsha, Hunan Province. This 50-story skyscraper was assembled in just 19 days, with workers averaging 3 floors per day. The achievement was made possible by prefabricated modular construction methods. Each of the building's 2,736 modules was manufactured off-site under controlled conditions and then transported to the construction site for rapid assembly. This approach not only slashed construction time but also reduced waste, minimized errors, and ensured high quality. The success of Mini Sky City set a new global benchmark, proving that skyscrapers could be built in weeks instead of years. Another record-breaking project came in 2020, during the COVID-19 crisis. In Wuhan, the Huashinshan Hospital was constructed in just 10 days to provide critical medical care during the outbreak. The project began on January 23 and was fully operational by February 2, housing 1,000 beds. Once again, prefabricated modular units were the key. By preparing site foundations and building modules at the same time, China saved valuable days. Each unit was produced with precision, allowing workers to assemble them like giant building blocks. Over 7,000 people, including engineers, electricians, and volunteers, worked around the clock in shifts. Massive fleets of cranes, trucks, and heavy equipment kept the site in constant motion. Coordination between government agencies, construction companies, and suppliers ensured materials and equipment arrived without delay. In just 10 days, a modern hospital rose from the ground, something no other country had ever achieved on that scale and speed. These remarkable projects were made possible not just by manpower and careful planning but also by China's advanced construction machines. The country has invested heavily in developing state-of-the-art equipment capable of handling projects that once seemed unthinkable. One of the most impressive of these machines is known as the Iron Monster. The SLJ-932, nicknamed the Iron Monster, is one of the largest bridge-building machines in the world. Built by Beijing Wao Joint Machinery Company and designed by the Shijiazhuang Railway Design Institute, this behemoth measures 91 meters in length, 7 meters in width, and nearly 100 meters in height. At 580 tons, it is heavier than some warships and ranks among the longest land vehicles ever created. This machine is specifically designed to build massive bridges by lifting, moving, and placing enormous beams with pinpoint accuracy. Its size, strength, and efficiency allow China to construct bridges in record time, something that would take far longer using traditional methods. The Iron Monster is just one example of how China's machines are reshaping skylines and landscapes across the world. These machines symbolize not just engineering power but also a vision of development that prioritizes speed, efficiency, and innovation. Whether it's tunnels, skyscrapers, hospitals, or bridges, China has shown again and again that no challenge is too large if you have the workforce, technology, and determination to meet it. China is changing the game of construction with machines the world thought were impossible. The Iron Monster lifts entire bridge spans weighing nearly 1,000 tons and places them with flawless precision. Then comes Kunlun, the first transport-erect machine able to handle 1,000-ton box girders across mountains, rivers, and even the sea, building in months what once took years. These engineering giants cut costs, save time, and push technology beyond anything the West imagined. And just when you think it can't get bigger, meet the XCMG XGC 88000, the most powerful crawler crane on Earth. These mega machines aren't just building bridges and railways, they're building a new future, one colossal project at a time. On paper, it almost seems impossible to imagine a crane that can lift 4,000 tons with a boom stretching 144 meters into the sky while weighing more than 5,300 tons itself. To give an idea of its power, this machine could easily hoist a fully loaded Airbus A380, one of the largest passenger planes in the world. This is the XGC 88000, an ultra-heavy crawler crane designed and built by XCMG. It first entered production in 2013 and immediately claimed the title of the largest tracked mobile crane on the planet, even surpassing Germany's famous Liebherr LR 13000. It is also ranked among the largest self-propelled ground vehicles ever created, outsizing even NASA's crawler transporters that were once considered unmatched in scale. While the Honghai crane holds records for sheer size, the XGC 88000 stands alone in its combination of power, mobility, and versatility. The crane itself is divided into two main sections. The first section is the body of the machine, equipped with a maximum boom length of 144 meters and an overall length of 173 meters when including the counterweight radius. It towers at a height of 108 meters and has a lifting capacity ranging from 3,600 to 4,000 tons. In practice, it has been pushed beyond its limits, successfully handling overloads of up to 4,500 tons. Its lifting moment reaches an astonishing 88,000 ton-meters. To power this giant, 3 Cummins engines are installed, each producing 641 kilowatts. Combined, they generate nearly 25,579 horsepower, giving the crane enough strength not only to perform its massive lifting tasks but also to handle assembly, disassembly, and backup operations. Inside, the operator's cabin feels more like a small office than the cockpit of a machine. It is spacious, air-conditioned, and even includes a comfortable chair and a sofa that can seat 3 passengers. This design ensures that operators can manage long and complex lifts in comfort and safety. The second major section is the tracked counterweight compartment. This section stands 9.7 meters tall, stretches 29 meters in length, and weighs a staggering 2,900 tons on its own. It includes its own driving cockpit and requires a working radius of about 29 meters. Combined, the two main sections give the XGC 88000 a total weight approaching 5,400 tons. The crane was specifically developed for use in industries that demand extreme lifting power and precision, such as petrochemical plants, nuclear facilities, and chemical factories. Its boom is designed to be flexible, offering different configurations depending on the task at hand. It can be set up with a 120-meter heavy boom, a 140-meter light boom, and even an additional 33-meter jib extension. This flexibility allows it to adapt to various construction environments and perform lifts that most other cranes could not attempt. Perhaps even more impressive is its ability to maintain full load shifts, which means it can move heavy loads while remaining mobile and efficient, something that sets it apart from other cranes of its size. Since entering service, the XGC 88000 has lifted modules that are larger than small buildings, executing projects that would leave conventional cranes struggling. Watching this machine in action feels almost like watching gravity itself bend to human engineering. Each lift it performs pushes the boundaries of what was once thought possible, and it has achieved feats that Western engineers decades ago would never have believed a mobile crane could accomplish. It is more than just a tool, it represents the scale of ambition driving China's rapid development. Yet China's engineering ambition does not stop with cranes. Even in tasks that might seem ordinary, such as pumping concrete, Chinese engineers have transformed them into extraordinary feats of scale. One of the clearest examples of this innovation is the Pump King. When the Shanghai Tower was being built, workers faced a unique challenge: how to pump concrete almost 2/3 of a kilometer into the air. For most machines in the West, pumping concrete a few hundred feet is already near their limit. But China's Sany 86-meter pump broke all expectations. It shattered the world record by pumping concrete 621 meters high, a distance greater than the height of the Eiffel Tower. This record-breaking performance earned it the nickname Pump King. As of 2024, the Pump King still holds the Guinness World Record for the longest truck-mounted concrete boom. This achievement is due to its highly advanced design, use of cutting-edge materials, and precise engineering. Its boom is made up of 7 sections, making it longer and more flexible than the typical 5 or 6-section designs used elsewhere. This extra reach allows operators to navigate tight spaces in crowded cities or complex terrains where construction is difficult. The boom is constructed from high-strength steel rated at 1,800 megapascals, ensuring it stays stable under extreme pressure during high-rise pumping operations. The Pump King is mounted on a 9-axle all-terrain chassis that provides both strength and mobility. Its advanced suspension system and multiple steering options, including crab steering and diagonal steering, make it possible to maneuver in narrow or challenging spaces. Operating the Pump King is just as impressive as its physical structure. It comes with an automatic boom system that enables one-touch deployment, vertical and horizontal pumping, boom locking, and even area-limiting features. Its advanced stabilization technology reduces boom shaking by 50% and minimizes the swinging of its revolving tower by 60%. These features not only make it safer to operate but also ensure that construction crews can pour concrete with pinpoint accuracy. Energy efficiency has also been built into the Pump King. It includes technology that boosts operational efficiency by about 25% while reducing fuel consumption by around 10%. Its self-diagnosis system is capable of detecting more than 150 different types of malfunctions. This means operators can quickly troubleshoot problems and minimize downtime, which is essential when working on large-scale projects where every hour counts. The Pump King has made a global impact on how skyscrapers and large-scale projects are built. For the Shanghai Tower, it successfully pumped ultra-high-strength concrete 620 meters into the air, setting a world record that still stands. Its ability to deliver concrete to such extreme heights with both precision and safety has allowed China to build taller and more complex structures faster than ever before. Durability and low maintenance were also key goals in its design. For example, its piston can handle between 25,000 to 30,000 cubic meters of concrete before needing replacement. Many of its components are built from advanced materials designed to resist wear and tear, giving the machine a long service life even under constant heavy use. The story of machines like the XGC 88,000 crane and the Pump King shows that China is not only keeping up with global engineering challenges but also setting new records and redefining what the future of construction looks like. From lifting modules the size of buildings to pumping concrete higher than the Eiffel Tower, these machines are proof of how innovation, ambition, and relentless engineering discipline can transform even the most ordinary tasks into world-shaping achievements. Each new development shows that China's approach is not just about building for today but about designing machines that will carry its infrastructure, economy, and global influence into the future. China's CYP 500 track laying machine has completely transformed how railways are built. This massive machine is capable of laying up to 2 kilometers of track in a single day, running non-stop for 24 hours and turning railway construction into a continuous and highly efficient process. In March 2020, the CYP 500 made its debut in Southeast Asia on the China-Laos Railway. There, it installed a 500-meter section of steel track in Vientiane, marking the first completed portion of the line and the longest steel track outside China in Asia. The machine performed so smoothly that it easily surpassed its daily goal of 1.5 kilometers, laying track with remarkable accuracy and speed. The CYP 500 was designed specifically for large-scale, high-capacity projects. It combines multiple functions, track laying, alignment, and precise placement, into one automated workflow. This integration reduces downtime and keeps the process moving without interruption. Its advanced control systems ensure that rails are placed with millimeter-level precision, even when working through difficult terrain, complex curves, long bridges, or deep tunnels. In just 4 years, this technology has boosted China's track laying capacity from 500 meters to an impressive 2 kilometers per day. The CYP 500 has set a new standard for speed and efficiency in global railway construction, enabling projects that would normally take years to be completed in a fraction of the time. But China's pursuit of engineering breakthroughs is not limited to railways. The construction of towering skyscrapers has also been transformed by machines like the Bonot, a wall-climbing construction giant designed to revolutionize high-rise building. Standing more than 40 meters tall and weighing nearly 2,000 tons, the Bonot dramatically speeds up the process of constructing tall buildings. With its help, a single floor can be completed in just 4 days, more than 20% faster than traditional methods. Unlike conventional cranes that rely on scaffolding and external supports, the Bonot operates on its own reinforced steel frame. Its integrated hydraulic and automated systems give it the ability to lift and assemble prefabricated panels, beams, and girders with complete stability, even at extreme heights. The machine is equipped with advanced sensors that constantly monitor stress, tilt, and load distribution. This system ensures that structural elements are placed correctly and safely, preventing errors that could otherwise compromise the building. What makes the Bonot especially remarkable is its ability to climb vertically without disassembly. Once it completes a floor, it hydraulically lifts itself to the next level, supported by jacks and counterweights that maintain perfect balance. Automated controls adjust for environmental factors like wind or structural shifts, allowing the machine to continue working without interruption. This continuous vertical mobility means that construction crews do not have to waste time moving or repositioning equipment, which significantly accelerates the overall pace of work. The Bonot is also heavily automated, reducing the need for manual labor at dangerous heights. Its software and sensors align and adjust every component in real time, performing precise lifting and assembly with minimal human intervention. Operators can control everything from inside a protected cabin, watching detailed data on load distribution, material placement, and alignment. Intelligent algorithms automatically make small adjustments, ensuring the structure remains safe and stable during construction. Built from lightweight but extremely strong materials similar to those used in aviation and submarines, the Bonot is designed to withstand intense conditions. Redundancy systems, stabilizers, and counterweights prevent tipping or accidents, even in hurricane-level winds. By reducing human risk, while at the same time lifting, aligning, and assembling multiple components simultaneously, the Bonot ensures unprecedented speed without sacrificing safety. What is most surprising about these mega machines is that they are not confined to China's borders. Thanks to innovations in heavy transport, they can be moved around the world for international projects. This is made possible by specialized ships like the Yihong Jinyan 2, a semi-submersible heavy-lift vessel designed specifically for carrying oversized cargo and project machinery. The Yihong Jinyan 2 was purpose-built to handle some of the largest and heaviest loads ever needed in global construction, including 10-megawatt offshore wind turbines and their massive components. It is also versatile enough to transport raw materials like sand and gravel or carry vehicles and other irregular cargo. Its open deck is designed to maximize efficiency when moving enormous or unusually shaped objects, making it suitable for both coastal and offshore operations. Measuring 115.2 meters in length with a 26-meter beam and a depth of 6.6 meters, the vessel provides a highly stable platform for transporting heavy loads. Its enormous 2,000-square-meter deck can carry up to 6,000 tons of material, while its reinforced structures allow it to safely transport vehicles, including trucks weighing up to 60 tons. The ship's superstructure is located near the bow, which maximizes the deck space at the stern and makes loading and unloading easier and more efficient. Together, machines like the CYP500, the Bonaut, and the Yihong Jinyan 2 demonstrate how China has redefined the scale and efficiency of modern engineering. Each one is designed not just to complete a job but to transform the way entire industries operate, from railway construction to skyscraper building and heavy cargo transport. With speed, precision, and the ability to adapt to some of the most difficult environments in the world, these innovations are pushing global construction into a new era where projects that once seemed impossible are now completed with remarkable regularity. The Yihong Jinyan 2 is built with remarkable flexibility and strength, designed to handle some of the most difficult loads in modern engineering. Its adjustable pillars, modular deck fittings, and reinforced springboard system allow it to carry irregular or oversized cargo, including disabled ships, while evenly distributing weight across the deck to reduce stress. This makes it one of the most versatile heavy-lift vessels operating today. Its propulsion and positioning systems combine raw power with pinpoint precision. Twin main engines drive fixed-pitch propellers, supported by a bow tunnel thruster and a 4-point mooring system. Together, these features allow the vessel to maintain stability and precise placement even under strong winds reaching Beaufort Force 6. This capability means the ship can often operate independently without tugboat assistance, cutting costs and improving efficiency during offshore operations. Automation and intelligent technology take the vessel a step further. An advanced energy management system monitors propulsion, onboard machinery, and navigation in real time, ensuring optimal power distribution while reducing fuel consumption. Predictive maintenance tools provide early warnings of potential equipment issues, giving crews time to service parts before they fail. Combined with its modular deck and optimized load handling design, these systems make the Yihong Jinyan 2 not only efficient and safe but also environmentally responsible. The layout of the ship is designed with heavy cargo in mind. Its superstructure is located at the bow, leaving the massive stern area completely open for oversized loads. Engine ducts and exhaust funnels are arranged along the sides, keeping the deck clear for cargo operations. Removable pillars allow crews to adapt the space for different types of loads, while the reinforced springboard system provides extra stability when handling extremely heavy or uneven cargo. Purpose-built for offshore construction, civil engineering, and heavy transport, the Yihong Jinyan 2 excels in carrying massive wind turbine components, prefabricated building sections, and other oversized project materials across long distances. With a carrying capacity of up to 6,000 tons per voyage, it delivers both reliability and precision. This makes it especially valuable for renewable energy projects, large-scale coastal construction, and global infrastructure initiatives where stability and safe handling are critical. The Yihong Jinyan 2 isn't just a ship, it's a vital link in China's strategy to move its mega-machines and project materials anywhere in the world. With its robust design, intelligent systems, and unmatched versatility, it supports the kind of massive engineering projects that are redefining what's possible on land and at sea. Thanks for watching. Be sure to check out the videos on your screen now for more unbelievable engineering stories.